A lot of people have been buying ultrasonic cleaners for their workshops over the last few years, especially now China has been pumping these things out at extremely competitive prices. When I first trained as a mechanic over 20 years ago, they simply weren't in garages due to their high cost, and everything was really cleaned by hand or in a parts washer or acid bath, etc. So I felt left out and had to buy one to see if the hype is real or not. I won't bore you with the scientific magic on how these things work, but essentially it creates tiny explosions on the surface of the parts known as cavitation, and that's what helps clean them. These can also be extremely dangerous pieces of equipment, so later on in the video I'll also share some safety points about them. And if you do intend on getting one of these, watching those points is absolutely necessary if you value your health and in some cases your life. So let's get into the nitty-gritty. Usually one of my favorite methods for getting rid of really tough dirt and grime is to use a jet wash. It doesn't dissolve the dirt or grease, but it is very efficient at making it homeless. I do still use that method for the big parts that won't fit in here, but for small parts it does take a while to set up and it may blast that part halfway across your garden, which isn't ideal. I set myself a budget of 200 quid and I wanted something that had a 10-litre capacity so I could dump at least one or two medium parts like carbs in there at once. So firstly, a few of the specifications of the machine, and I purchased this with my own money. It was not sent to me for free. I managed to get this 10-litre cleaner for 130 quid on Amazon, which is an incredibly low price. It is missing some of the functions of more expensive machines, but generally those machines are at least twice the price and above my starting budget. And for quite a bit of saving, all it really means is I have to press some more buttons. It will heat your solution up to 80 degrees and a single cycle will run for up to 30 minutes. It has a more middle of the road cleaning action of 40 kilohertz. And it doesn't have a degassing function, but as I said, for the price saving, I'm sure I can live with that. I didn't just buy one cleaning solution, I found three, and I'll be comparing them and showing you the results. You can use other cleaning solutions, but if you do, be sure the container you're going to use isn't going to be affected by them. For example, some solvents will break down certain types of plastic. Petrol is a brilliant cleaning fluid, but I'm not going to be using it for safety reasons, and I'll get onto that later. I have before me 6 different items to put these solutions to the test, and I have 4 samples of each. One for a control sample that I will do nothing with, and one for each of the cleaning solutions. I wanted to get a mixture of different materials to not only see how well my potions perform, but also to see if they damage them in any way. Example, eroding, etching, or dulling the surface. Starting at the bottom, I've got a piece of the Ducati motorbike chain. Chain is there because it is heavily corroded, and chain oil by design tends to be very sticky and tough to clean indeed. This budget machine really does have its work cut out on this one. I'm not expecting it to remove the heavy amount of corrosion. I will be releasing another video about corrosion removal soon, but I did want to see if it would at least make a dent in it. The next is a piece of rubber to represent gaskets or O-rings. There are some chemicals that will destroy rubber in one way or another. Personally, I would clean it by hand, but I thought it'd be nice to see if there was any effect. Then I have a piece of brass chain to represent jets in carburettors. A piece of sheet aluminium that could be used for things like brackets. A stainless steel washer. I don't expect much to happen to this, but stainless is a commonly used component. Finally, I have a piece of zinc alloy that is heavily corroded. This is to represent the main body of a carburetor, as zinc alloy is preferred for casting due to its excellent fluidity. It is also generally one of the softer and more vulnerable aluminium alloys. Now, as I said, this tank has a 10-litre capacity, and filling that with purely solution would cost a fortune. So instead, I'm going to fill the tank with regular tap water up to the fill line, as part filling it will rapidly destroy the machine. You've been warned. A quick tip here, I'm going to get hot water from my household tap or faucet if you're American, as this will save heating up time and hopefully cost less energy. The parts themselves I'm going to put into a Ziploc bag. Add the solution to make sure they're covered and get most but not all of the air out to allow for any possible chemical reactions and discharge of gas. And then suspend them into the water. Suspending them also means you don't need to worry about them being perfectly sealed. I've just used household clothing pegs and strips of wood in the hope it'll absorb some of the vibration. Putting your parts in another container not only saves on expensive chemicals, but it also keeps your tank cleaner. You don't have to use bags, you could use glass or, in a pinch, plastic, but the plastic will absorb some of the vibration and lessen the cleaning action. Also, when doing this, you must sit the container in the basket and not on the base of the tank, as certain frequencies can actually shatter the glass. The best water to dilute your solution is de-ionized or distilled water. Essentially, it has all the impurities and minerals removed, which stops things like limescale buildup, and it does actually act as a solvent by itself. Another cheaper way that you could do this is to buy bottles of spring water. It would be slightly cheaper and still slightly better than regular tap water. Also, having the bottles means that you can pre-make your solution or even store your used solution in them to stop it evaporating over time. I use coffee filters to strain any particles out of it before putting it into a bottle. If it is heavily soiled from a dirty part, then just consider throwing it away or getting another bottle to save ruining your unused stuff, and the chemicals will break down over time. Right, that was a lot of information. Let's see how they do and then finish off with the results and some more tips and tricks at the end. Before I give the results, how much did they cost per litre? And believe me, this will be interesting later. The three solutions in no particular order are the Ultro Carb at £14 a litre, the Carbusonic at £24 a litre, and the cheapest, that was a quarter the price of the most expensive, was Best Ultrasonic at £6 a litre. They all say they'll do the same thing. The only difference looking at them is you pay an extra £18 a litre for Carbusonic because it's pink. From now on, I'm going to refer to them as Carb, Ultro, and Best to save too much repetition. So how do they perform? Firstly, the good news. None of them damaged the bright aluminium sheeting, stainless steel washers, or the brass. The brass was dull, and the one that cleaned it the most was Best, then Ultro, and the worst was Carb. I couldn't see any damage to any of the rubbers, but equally, as I said, I don't recommend putting rubber in anyway unless you either don't want it or absolutely have to. Now for some surprising news, the heavily corroded motorbike chains. All of the solutions removed a surprising amount of the corrosion and cleaned the chain up very well. Yet again, the best was Best, then Ultro, then Carb. There wasn't a whole lot of difference between the first two, but there was a lot more corrosion left on the worst one. Now for the bad and also quite surprising news. None of them performed very well with the corroded casting, despite all of them stating they are for use on carbs. They ranked exactly the same again, Best being Best, then Ultro, and then Carb. The difference between the Best and the Carb was actually quite substantial. So my conclusion, just because it's the most expensive and pink doesn't mean it's worth 4 times the price. Personally, I cannot see why you wouldn't just buy the cheapest of the three, as in every instance it performed the best. and the most expensive perform the worst. Go figure. Before you go, I did come across some concerns regarding these machines that I wanted to share with you. Obviously, I mentioned earlier about flammable solutions being a bad idea. Those tiny explosions I mentioned at the start of the video can momentarily increase the temperature quite dramatically and create a potentially explosive situation. Also, if you haven't fully disassembled the part and it still has screws, nuts or bolts, make sure you check they are still tight after the cleaning, as obviously vibration can cause movement. Another safety point that I came across is that you should under no circumstance touch the solution or anything in it when it's running, as it can destroy your joints and your skin. I've seen so many people simply holding the part or even dipping their hands directly into the solution. Okay, now for probably the most dangerous point alongside using flammable liquids. Research the chemical that you want to use in your cleaner. Back to those pesky bubbles again. They can accelerate the release of gases. For example, chlorine gas with bleach or hydrogen gas when using acids on reactive metals such as zinc alloy. And most people don't know mixing bleach and acid will happily create chlorine gas, so that is 100% no. If in doubt, either don't use it or at least put the machine outside. I tried to make this as comprehensive as possible without going too far, but if there's anything I missed, any chemicals you would like to see tested, or even if you found this helpful, even a little serious at times, please drop it into the comments. For the next video, I am going to see if I can find an effective way for removing or at least neutralizing rust with this.